In this lesson, we're going to take a look at the MIB texture vector node and how it can be used to control the placement of our mental ray textures. So in this scene, we have just a basic signpost set up, and connected to this signpost, we have a mental ray Lambert, and that in turn has a mental ray texture connected to it. Now you'll notice that even though we have a texture connected, that it doesn't show up properly in either the texture swatch or on the material itself. So with a lot of these mental ray nodes, if they're going to be applied in some sort of a mapping method to our object, we will need to take advantage of this mental ray texture vector node. So let's drop this in, and really this can be used on any node that is asking for some kind of coordinate information. That's really what this node is designed to provide. So let's go to this MIB texture node. This texture lookup is what we're using. So we'll take our vector, middle click, drag it into the coordinates, and you'll notice immediately that the texture is now displayed correctly. So let's take a look inside this texture vector, and you'll notice that we really just have a few attributes to choose from. So let's go back to our render view, and you'll notice that the image in the viewport actually shows up pretty much upside down, but whenever we render, this should show up correctly. So really this is just a viewport error. So let's take a look at some of these attributes found on the texture vector node. So you can see right now we have the selection space. Now this is controlling the actual projection method or the lookup method that is used. For most situations, a value of 0 will work fine, but we do have the ability to take this and use different lookup methods as far as different vectors and different UV coordinates to project this image. So we can actually take this up to 63, I believe, different lookup methods. But as I mentioned, for most situations, the selection method of 0 should work just fine. Now below that, we have the selection space. Now this is something that is fairly important to take note of. This is allowing us to actually project this image based on either the orientation of the object or the orientation of the camera or this object's orientation in the render view. So with the selection space set to standard, you can see that the image fits rather nicely on this piece of geometry. Now let's save this for comparison and set the selection space now to an object space. In the viewport, everything will look just the same, but whenever we render, you'll notice now that the texture really doesn't fit correctly. And the reason is because now this texture is using the actual translate values, or the transform values that are found on this particular object. So this piece of geometry, we have it rotated -10 degrees in the z-axis. And so as a result, the texture itself will rotate itself an additional 10 degrees. So this is a way of kind of helping your textures to align to an object if it doesn't have any sort of object space translate values assigned to it. For most situations, though, you will probably want to leave this set to a world space value. Now just below that, we have, like I said, the world space. This is actually the same thing as the standard mode. You'll notice that if we set this to a world space and render the image, that it looks really just the same. Now just below that, we have the camera mapping method. Now this will look at the camera's coordinates and then project the image accordingly. Now right now we have our camera angled in a method where the image itself really doesn't show up at all. We're just left with the black space. And just below that, we have the screen mode. Now this one's sort of interesting in the fact that whenever we render, you can see how the texture is now very prominent on this image. Now let's save this for comparison, and you'll see really what this is going to be doing. Save this, and I'll move my object over just a little bit and re-render. And what you'll see is that the object itself is able to move, but the texture stays right where it is. So really you can think of this texture as occupying the entire screen area of our rendered image. And by just simply moving the object, we're now just changing which area of this texture is being displayed on this particular piece of geometry. So for most situations, you will probably want to leave this set to either standard mode or an object, or rather a world mode. Now below this we have the ability to change the actual projection method that's being used. By default this is set to none, which means it will read the UV texture information that's been applied to this particular piece of geometry. Now we can override that if we were to set this to something like UV, which again will now start to read the UV information, or we could actually project this in its own direction as well. So right now this is set to an XZ projection, which should now be projecting this a little bit more from the side. And you can start to see the black areas right over here where the image is actually being projected from this particular angle. So that's how this is determining the projection method. So we can choose to project this from a different angle. We can choose more of a spherical map, which will try to wrap the image around the object. We can also use a cylindrical map or a lollipop method, which will try to project this from one of the corners of our mesh. So that's a look at some of the features that are found on this MIB Texture Vector node.